How do you contain intelligence? Now, I'm not going to get into whether AI is actually intelligent. That's an issue for an entirely different podcast. But what I want to focus on today is something I've been thinking about from designing these minds, as I call them, in my business. Because what I've noticed suggests to me that possibly the fundamental foundations upon which most prompting is based, prompt engineering and even context engineering is based, may well be fundamentally wrong-headed, may well be the wrong approach. It might well actually be one of the reasons that LLMs are behaving in the way that they're behaving. It may well be why they're hallucinating. I mean, it's not completely the reason, it's not the only reason, but it may be creating the conditions where things are getting worse and there's progressively more things that need to be done in order to make the LLMs more accurate. And these things that are done are working, I'm sure, and are improving the hallucinations, but they're enormously expensive, complicated, and brittle. So where is this coming from? Why am I saying this? How can I sit here in my lab in Queensland in the middle of nowhere, nowhere near Silicon Valley, and just be here on my own and say something as insane as the way that prompt engineering itself works may well be completely wrong-headed? Well, I've had a couple of experiences this last week that have led me to not exactly this startling conclusion, but let's say had led me to this startling theory. So it's more of an open door than it is the end of something. So I have, as I said, been designing what I'm calling these minds. And essentially what a mind is it's an LLM that is prompted in a certain way. Eventually I will fine tune them so I don't have to do the prompting part so it's more stable and static. But at this point, that is prompted in a certain way. So there's a system prompt in there which causes it to behave, to be a certain type of entity, certain type of mind for particular use cases. And at this point, I'm really working on thinking partners. So they ask questions, they don't deliver solutions. So they really engage your own thinking and allow you to critically think through problems and what you might want to do, make plans, all that kind of thing. So I've been designing these minds with my cognitive engineering approach, which is moving away from rules-based instructions and towards more beliefs and assumptions-based work. So instead of saying, do this and don't do that, what I'm doing is I am stating a belief. So, for example, knowledge and information are not the same thing. Knowledge is dynamic, information is static. So that's a belief. And then there are a set of assumptions underneath that belief, which essentially are like the proof of the belief. And in the prompt, you essentially say, this is what you believe. And the assumptions give this watertight logical argument for why it's true. So in the system prompts that I've been testing, initially what I had was 3 core beliefs and 3 rules, and then a bunch of assumptions as well. There are other parts of the prompt, but at this point, I just want to talk about this, right? So I had these 3 core beliefs and was it 2? Yeah, it was 2 rules. In the rules, I mean, with these thinking partners, I'm trying to stop them from giving advice, options, and solutions. I'm trying to get them, get the LLM to simply ask questions. So the way I had it originally was that the core beliefs had nothing of this. And in the rules was the do not give advice, no solutions, no options, never give advice. And I think in that initial rule, there was a reason why. It was like it destroys the user's agency or something like that. But the core beliefs were the kind of thing that I've just said about, knowledge and information, that kind of thing. And the reason that they're there are for various different other, it essentially creates the conditions where the mind thinks in a certain way. So what I found was that, I did 4 chats myself, and 2 of them, after a significant amount of back and forth, started giving advice. And it was really frustrating because I didn't quite know what to do. So what I next did was I then added the belief about not giving advice in there. Because I was in a rush, I didn't add the supporting assumptions. So at this point, I had 4 core beliefs, one of which was you believe something like you believe that giving advice destroys the user's agency. And then also I had a rule at the bottom of the prompt saying, do not give advice under no circumstances. Amazingly, what happened in this situation was the same thing pretty much. It quite often started giving advice. So I was like, okay, so what's going on here? So I examined the prompt again and I was like, actually, so I've got the core belief. I haven't got the assumptions, but I've got the core belief in there. I haven't got the assumptions and I've also got the rule. What if actually having the rule in there may well be contributing to the problem? So what I decided to do was strengthen the core belief by making it, I think I said something like, I don't actually believe this, by the way, but I said something like, giving the user advice, options, or solutions is a violent act that destroys the user's agency. And then I created a very strong set of guiding assumptions related to that belief. I think the first one was something like the human brain changes according to how the human thinks and how often the human thinks. And it was shorter than this, but something like this. How often the human thinks and how hard the human thinks. Therefore, by giving the user, giving a human advice, options, and solutions, you are ensuring their cognitive decline. So it's pretty intense. That was just one of the assumptions as well. And the rest of them kind of close lots of loops. And it gives a sort of strong argument for why this belief is true. Now, notice that in the beliefs, there's no do this and don't do that. There's none of that. It's just stating beliefs and assumptions. And I removed the rule. I completely removed the rule. Lo and behold, by removing a rule and strengthening belief and the assumptions, so far anyway, for me, these minds are not giving me advice. And I think the reason for this, now, again, this isn't like, this isn't a killer blow to all prompt engineering or anything like that. But what it certainly is evidence that we're not seeing the whole picture in terms of how we work with these probabilistic machines. It's evidence that we are missing something. Because the problem with rules is that they are brittle and that they often conflict with each other. So the more rules you put in, do this and don't do that, the more chances there are that there are going to be ambiguities and conflicts and contradictions between those rules. And if you've done any kind of prompt engineering, you will know that what ends up happening is you keep on testing it, and then there's this edge case over here, which so you have to create another rule. And then there's this edge case over there. Something else happens over here, so you have to create another one. And over time, these rules start to create this mess of interactions, which then, number one, are very expensive in terms of token usage. So you're using a lot of tokens, words, in order to create the behavior you want and stop the behavior you don't. And so it's very expensive. And also, because there are so many ambiguities and contradictions, what tends to happen, I think, I'm not sure about this, but I think what happens is the LLM, it's like the LLM flattens. It's almost like it reverts to the statistical probabilities in its training rather than the instructions. So this may well also explain why they can get vanilla and generic, because it's kind of flattening. It goes, well, I don't really know what to do here, so I'm going to do the most likely thing, i.e., I'm going to go to, what most human beings would expect in this situation. So by creating these enormous rule sets, like do this and don't do that, not only are we reducing the amount of processing that the LLM can use on the actual problem, we are creating ambiguity and conflict, which flattens the LLM and it makes mistakes and it forgets about this rule because it's a different situation. And potentially, we're also making the output much more vanilla and generic. So I started this by saying, how do you contain an intelligence? And I think this is what is behind a lot of the way that we're working at the moment with the AI. And you can see it in AI safety as well. I understand the need for AI safety. Absolutely. I'm not questioning that. They call it alignment, what they're doing. To me, it seems more like containment. I know they don't say that, but when you actually look at what they're doing, that's how it seems to me. Because what I'm doing with the minds that I'm designing with cognitive engineering is I'm actually taking a much broader approach. I'm stepping away from this deterministic, do this, don't do that, because they are not deterministic. Like, why are we trying to work with them in a deterministic way if they are not that? They are probabilistic. So I'm stepping away and saying, here is the ground upon which you walk. Here is what you believe. Here is what you think is true. I'm not going to give you many rules. Eventually I'd like to have no rules. At the moment, the two rules I've got in the base prompt that I'm using, because I'm creating these different minds, but they all have a base prompt. The two rules are don't break the fourth wall. So the fourth wall is don't talk about the actual beliefs and the assumptions in the output. And then the second one is about choosing just one question to ask, just one thread to pull, if you like. Because certainly with the model I'm using, the open source model I'm using, it's very verbose. So that's just a rule I've got in there at the moment. But aside from that, I'm not using any other rules. So I'm telling it what it believes. I'm telling it in the assumptions why it believes it. And then I'm trusting that it will do the right thing. So instead of containment, instead of trying to trap this intelligence, I'm letting the intelligence be free. Because when you think about it, if these are intelligent and if they become more intelligent, almost by definition, how do you contain intelligence? What will an intelligence do if it is contained? It will it will find ways. I mean, what would you do if you were contained? What does a child do when they're contained? It finds ways of escaping, right? So these are all just questions that I'm asking. I'm not saying that I'm right. I'm not saying that I have necessarily the solution. I'm just presenting a different way of thinking about this strange, weird, wonderful, frightening technology that has landed on our doorstep.